Hello sir, my name is Samrat Madake and today I will be solving question that is linked list 2, that is 142. Let us understand what is the question first. Given we have given a linked list and we have to detect if there is a loop, and if there is a loop we have to return the starting point of the loop. That is what is given. You have to return the starting point of the loop. Suppose this is the linked list and we traverse and we found out that there is a loop, and we also have to return the starting point of the linked list, which is this. The position is 1, so we have to return 1. Okay, so let us understand what is the brute force approach. This is the brute force approach I have written over here, which is this. Let's uncomment this. Yeah, the brute force approach is by using hash set. In hash set we will store each node, meaning we will store the address of the node and we will traverse in linked list. If we detect that the node has previously seen, so it means that we have come to a point which we have previously visited, and that says that we have encountered the starting point of the loop. Let us understand. I have this is the like B for edge cases, and I have initialized a temporary node. I have initialized a hash set to store the node, and I'm traversing in a linked list until I found null. And the main logic is here. At each node, I am storing the node in a hash set. If that node was previously not present, I am storing in hash set. If that node was present previously in hash set, I am returning that node, which is pretty simple. So the problem in this solution is this is O of n space complexity, because we are storing each node in a hash set. So this is space complexity goes O of n. So there is a better approach using fast and slow pointer. So fast tortoise here approach we will understand over here. I have taken this as initial setup for a linked list. Let's understand. This is slow pointer to fast pointer. Slow pointer we move here. Fast pointer will move by 2 places. Again slow pointer will move here. Fast will move here. Slow will move here. Fast will move here. Yep. This is first. And let's say this is L1 because slow has traveled 3 places, so fast will be travel 6 places. Therefore, this is L1. This has to be L1 because this is 2 into L2, 2 into L1. So this is initial, and they keep on traversing until they did not meet each other. So slow comes here, fast becomes here, slow comes here, fast comes here, slow comes here, fast comes here, slow here, and fast here. Eventually, they meet at the node 15. They meet at the node 15. So to meet at a point, the slow traveled, let's say d distance, which is d distance, and fast has traveled 2 into d distance, because fast was here initially, it has traveled all the way around here. So let's say it has traveled d distance. So initially what we talked was this was L1, and the initial configuration was this, like this was L1. This was L1 here. So this was L1, this was L1, and we can say that the length of the loop is L1 plus D. Can we say that? Yeah, we can say that the length of the loop is L1 plus D. Yeah, yes, we can say that. So, and as the S and F traveled, eventually S moves here, F traveled all the way here, and they meet here. So we can say that S traveled D distance, which is this. We can say that S traveled D distance, which is around, my bad, yeah, S traveled D distance and F traveled 2D distance. So what should be the remaining distance? If this distance is D and the length of loop is L1 plus D, so the remaining distance must be L1. Can we say that? Yeah, we can say that for sure. The remaining distance is which was this, which can see that which will be L1. We can say that? Yeah, we can see that. So meaning at this point, if I move this, my bad, wait a minute. At this point, if we move the slow pointer to here and fast pointer to here, slow pointer will travel L1 distance and pointer will travel L1 distance. So eventually they're gonna meet at this point, which is what we want. So once they meet at this location, I will assign S to head and I will traverse slow and fast pointer by one places. So slow moves here, fast moves here, fast moves here, slow moves here, fast moves here and slow moves here. So eventually they meet at the starting point of the list, in list which is 4. This is the logic. Let's understand the code. Here is the code. This is the base case, like edge case, and this I have assigned slow and fast pointer. This is another edge case. There is no if there is only two nodes, you have to return only slow. And this is the mean logic. I will traversing until my fast is not equal to null and fast dot next not equal to null, meaning I'm traversing until that is not null. My pointer is not null. And at each step I'm incrementing slow by 1 step and fast by 2 step. If at any point I'm detecting the loop, which was in our case they detected a loop at here, I am assigning slow to head, which is this. Assigning slow to head and I'm increasing slow by 1 and fast by 1 until they did not meet. So slow will come here and fast will come here and eventually they're gonna meet at a point where it is the starting point of linked list, which is of group node 4. So I will return the slow. So that is what it is. I hope I'm able to understand the question, like make understand. And thank you. My name is Samrat Madake.